Hey everyone, here's our math problem for today. This is taken from the PUTNAM 1998 mathematical competition. A right circular cone has a base of radius 1 and height of 3. A cube is inscribed in the cone so that one face of the cube is contained in the base of the cone. What is the side length of the cube? For those of you who are asking what is this PUTNAM mathematical competition, according to Wikipedia, it is widely considered to be the most prestigious university-level mathematics competition in the world, and its difficulty is such that the median score is often 0 out of 120, despite being attempted by students specializing in mathematics. So that's how difficult this math competition is. Now let's go back to the problem. You can pause the video and see if you can solve this difficult math problem. Now let's solve this problem together. So let's draw first the figure. We have this right circular cone and we inscribe this cube. It is given that the height of the cone is 3 units and the radius is 1. So in here, segment AB is 3 units and segment BC is 1 unit. We draw the figure in 3-dimensional space. We would like to find what is the side length of the cube, and let's denote it as S. Now let's concentrate on this one face of the cube. Now this face is a square. Let's analyze this face and let's look at this from the top view. Now, since the diagonals of the squares are equal and they bisect each other, then what we have here is a 45, 45, 90 special triangle. This side here is our S, and from the properties of this special 45, 45, 90 triangle, each of the sides are equal to square root of 2 over 2 times that of the length of the side. So that means the length of this line segment here is square root of 2 over 2 times S. The length of this line segment is just the same as the length of the side of the cube, S. That is because we are looking at the projection of this 3-dimensional object. Now in here, we form two similar triangles. Let's analyze these two similar triangles. The first one is this purple right triangle, and its dimensions are, the height is 3 units and the base is 1 unit. This is a right triangle. The other triangle is this pink triangle that is similar to this purple triangle because this angle here is this angle. They're the same. They're both right triangles, and therefore the third angles are the same. So what are the dimensions of this pink triangle? Notice that the height of this would be the height of the cone minus this part, which is S. Therefore, its height is 3 minus S. The base of this pink triangle is this distance, which we said to be S times square root of 2 over 2. And these two right triangles are similar, and therefore we can now form a proportion. The height over the base of the purple triangle is 3 over 1, and the height over the base of the pink triangle is 3 minus S over S times square root of 2 over 2. We simplify the right side by multiplying 3 minus S by the reciprocal of S times square root of 2 over 2 to arrive at 6 minus 2S over S times square root of 2, and 3 over 1 is 3. Multiply both sides by S times square root of 2 to arrive at 3 times square root of 2 times S equals 6 minus 2S. You have a variable S here and another variable S here. We combine like terms in one side of the equation, and finally we arrive at the quantity 3 square root of 2 plus 2 times S equals 6. And solving for S is equal to 6 over this binomial 3 square root of 2 plus 2. Then, let's rationalize the denominator by multiplying by the conjugate of the denominator. Multiplying the numerators, we arrive at 6 times the quantity 3 square root of 2 minus 2. And at the denominator, we have the product of the sum and difference of two numbers, which is equal to the difference of the squares of the two terms. So the square of 3 square root of 2 is 18. The square of 2 is 4. We get the difference. 18 minus 4 is 14. Simplifying 6 over 14, both are divisible by 2. So we have here 3 and here we have 7. Then finally distribute 3 to the binomial to arrive at 9 square root of 2 minus 6 over 7, which is approximately equal to 0.961132. So going back now to our original problem, the side length of this cube is 9 square root of 2 minus 6 all over 7. And this problem is now solved.